Hello everyone, welcome to Hussein Physics Academy YouTube channel. Today we discuss JEE 2025 April session questions. So for that we go to first question. So first question is given the battery of a mobile phone battery is rated as 4.2 volts. So mobile phone battery rating is given, voltage is given 4.2 volts, V is given 5800 milliampere hours. This is the, let us consider as charge Q. Why? Because during the charging period it will given. So how much energy will be generated or stored or supplied? So formula is energy supplied or energy stored during during charging during charging. E is equal V into Q. So V value is 4.2 into Q value is 5800. Yeah, milli is 10 to the power of minus 3 given in milliamps. So hours is given milliampere hours. So 1 hour is equal to 60 minutes. 1 minute is equal to 60 seconds. So totally hours is converted into seconds. So he is equal 4.2 into 5800 into 10 to the power of minus 3 into 6 into 6 36 double 3600. So finally we get answer is 87.69 volts. So approximately we consider as 87.7 volts. This one is the our final answer. Option 3 is correct. Next, in an adiabatic process, which of the following statement is true? So in an adiabatic process, which of the following statement is true? So we know that in adiabatic process, Q is equal to constant. Q is equal to constant. In adiabatic process, Q is equal to constant. So remember this one. In adiabatic process, heat is constant. So in thermal process, temperature is constant. Isothermal process, temperature is constant. Isobaric process, pressure is constant. Isometric, so like that. So remember you have to all the processes, what are the parameters are constant. So okay, so here the molar heat capacity is infinite, so this one is wrong, not infinite. Next, the work done by the gas is equal to the increase in internal energy. So this one is also wrong. Why? Because work done is equal to minus of du. Minus means change, decrease in internal energy. But here is given increases. So this one is also wrong. Next, third one. Third one is the molar heat capacity is 0. Okay, molar heat capacity is 0. Yes, this one is the correct. Molar heat capacity is 0. Why? Here because here delta Q is equal to constant now. So when the Q is equal to constant, delta Q is equal to 0. So Q is constant means change in internal energy is 0. So when the change in internal energy is 0, we know that formula for specific heat capacity delta Q is equal to NCP delta T or NCV delta T. So put here delta Q is equal to 0, then Cp delta T. So Cp is equal to 0. Similarly, Cv is also same formula for volume constant value NCV delta T. So Cv is also becomes 0. So both capacities, specific heat capacities are become 0. But fourth option is the internal energy of the gas decreases as the temperature increases. Always temperature is directly proportional to internal energy. When internal energy increases, temperature increases. Or temperature increases, internal energy is increases. So, but here given inversely proportional process. So, fourth one is the wrong. Okay. So that's why our answer is third one. Molar heat capacity is 0. Next one, if mu and epsilon are the permeability and permittivity of free space respectively, then the dimension of 1 by mu epsilon is, so here given, so we know that formula for velocity velocity of sound velocity of sound c is equal 1 by under root of mu epsilon is equal 3 into 10 to the power of 8 meter per second. This value is equal to this formula. Okay, so squaring on both sides 1 by mu epsilon whole square. Now the c square is equal 1 by mu epsilon. We know that the formula for c means here velocity. So velocity dimension lt minus 1. So here square is there is equal to 1 by mu epsilon. So L square t minus 2 is equal to 1 by mu epsilon. So from this L square by t square is equal to c 1 by mu epsilon 1 by mu epsilon. So here L by L square by t square, answer 2 is correct. Next question. So here Gina diode question is given. A energized diode with 5 volts Gina voltage. 5 volts Gina voltage is given Vz. Next, voltage is used to regulate an unregulated DC voltage is input of 25 volts. Vi is given input voltage. And 400 ohms resistor connected in series. So 400 ohms resistor series resistance given. Here condition is the energized current means Zener current is found to be 4 times the load current. So Iz is equal to 4 times of load current. Condition is given. So what is the value of current IL and RL? So load current and load resistance we have to find. Okay, we have to find. So for that, so first I am taking here eraser. So first for solving the problem, first whenever the question is given on the Zener diode, draw the circuit firstly. First of all, we have to draw the circuit. Then we get we get the answer very easily and within less time. So Gina diode circuit is here. This one is the Gina diode. So this one is the load resistance. Here this one is the series resistance. R is equal to given 400 ohms. This one is the input voltage plus minus. V input is equal to 25 volts. Here Vz is equal to 5 volts given. Here RL is we have to find. The current flowing through this load resistance is IL is equal to question mark. We don't know. So the current flowing through this resistance is I. The current flowing through this diode is IZ. Okay. So to find the load current, we have to apply Kirchhoff current law to the whole circuit. So the statement of Kirchhoff current law is sum of the currents entering the node is equal to sum of the current leaving the nodes. So here let us, here this one is the node. So here I current is entering to this node, IZ current is leaving this node. Here IL current is also leaving the node. So these two are leaving, this one is entering. So entering current is equal to the leaving currents. Entering current is I. Leaving currents are IZ plus IL. IZ plus IL. So here condition is given condition IZ is equal 4 times of IL. Given condition IZ is equal 4 times of IL. So I is equal, substitute here in place of IZ 4 IL plus IL, total 5 IL. So IL is equal I by 5. So here IL value is we don't know. I value is also we don't know. Both are unknown values. So to find the I value, so apply KVL. So apply KVL, apply KVL to loop 1 only. So in the above circuit there are two loops are there. This one is the loop 1, this one is the loop 2. So we apply KVL to the loop 1 only. So for current I, to find the current I, so to get the current I value we have to apply KVL to loop 1. So first of all draw the loop 1, only loop 1 circuit. So here plus, here this one is the Gina diode. Here voltage 5 volts is given already. Here this one is the 25 volts. This one is the 400 ohms resistance. Here we have to find this current I. So KVL means algebraic sum of voltages is equal to 0. Remember that always in any circuit voltage source is considered as positive. First terminal, voltage source first terminal. Remaining components what are there, those components second terminals we have to consider. This one the first terminal, this one second terminal. This one first terminal, this one second terminal. So first only voltage source, main source is there, that source first terminal, and the remaining components second terminal or negative terminals we have to consider. So first consider main source. 25 volts. So remaining components second terminals here considered. So minus second terminal is minus here. So second terminal is minus. So minus where current flowing through this resistor is I into 400. Next second terminal of this diode is minus minus here voltage is given general voltage 5 is equal to 0. So 25 minus 5 20 is equal to 400 I. I is equal 20 by 400. So 0 0 get cancelled 1 by 20 amps answer I value. So but we have to find here IL value not I value. So IL value we have to find here. So IL is equal I by 5. So I value is 1 by 20 into 5 1 by 100 25 are 100. So here I am multiplying and divided by 10 into 100. So 10 100 into 10,000. So 10 milliamps. So load current is 10 milliamps. So second one is here find the load resistance. So to find the load resistance RL, we know that formula from the Ohm's law V by I. So V by IL. But V means here Vz by IL. Why? Because voltage across the load is equal to the voltage across the Zener diode. Why? Because in parallel circuit voltage is same. So Zener diode and load resistor both are parallel. So that's why. So I am considering as voltage across the load is equal to the voltage across the Zener diode. So 5 volts Zener diode voltage. So load current IL is equal to 10 milliamps. So 5 into 5 by 10 into 10 to the power minus 3. So 5 into 10 cube by 10. So here 110 is there, here 110. So total 500 ohms resistor load resistance is given. So our answer is here some typing mistake is there in the options. So type first one is the 250 ohms. Second option is 0.5 ohms. 0.50. This one is the 0.50. Third option is 250 ohms. Fourth option is 500 ohms. So our option is IL is equal to 10 milliamps. IL is equal to 10 milliamps and 500 ohms. 10 milliamps and 500 ohms. Our option answer is fourth one. 10 milliamps and 500 ohms. Okay. This one is our final answer. So this one is the today's session. So thank you very much. Okay, let us completed the today's session.